Hi, this is Dan Bullard, retired electronics engineer, sitting on the front deck of a houseboat again. I want to do a really short one. I'm in between potato trucks, and I've got these guys anchored out over here. I don't know what they're doing. Hopefully you don't make too much noise. So I want to talk about Law 6, and I wrote it up on LinkedIn. You can go read up on it. I did this graphic, and it's pretty cool. Here I'm clipping a sine wave at 66.8 degrees on the upper peak, and there's the time domain wave, and you can see the spectrum, and it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 humps. And that's the one I use in distortion. And then I clip the negative peak of the wave at the reciprocal angle, which is 246.8 degrees, and it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 humps. So 13 humps, the spectrum looks identical. What's the difference? How can you tell the difference? The way to tell the difference is to look at the phases, and the spectrum generally does not show the phases. And in a spectrum analyzer, it's not capable of seeing the phases. So here we have on the positive peak clipping, the auto harmonics are all the same with the negative peak clip. And so notice that you start with minus 90 degrees for the first harmonic. Why minus 90? Because what's a sine wave relative to a cosine wave? The FFT does all those calculations relative to a cosine wave. So with a sine wave, minus 90 degrees it's a sine wave relative to a cosine wave. So the fundamental is at 0 degrees relative to a sine wave, and minus 90 degrees relative to a cosine wave. But the even harmonics go 180, 0, 180, 0, 180, 0, 0, 180, 0, 180, 180. And for the negative peak clipping, the even harmonics goes 0, 180, 0, 180, 0, 180, 180, 0, 180, 0, 0. Exactly 180 degrees out of phase from the positive peak clipping. So the only difference between the positive peak clipping and the negative peak clipping, if you're at reciprocal angles, is the phases of the even harmonics are 180 degrees out. And for that reason, I was able to do this graphic where I move the distortion from one side of the wave to the other. And that's just by flipping the phases of the even harmonics 180 degrees. It's really, really simple. That's demonstrating Law 6 right there. Boom. Reciprocal angles, the spectra look identical. Notice the odd harmonics are all the same, all the way down. And there's a potato truck, so I better wrap this up. So it's pretty cool stuff. So once again from the river, this is Dan Bullard. See ya.